We're taking a deeper look now at these levels of protein structure, and we're focusing in specifically on tertiary and quaternary and these side chain attractions that hold this protein into the shape that we see here, or curled up into these different shapes here. So we're going to take a look at some of these different attractions that are labeled here and look at some examples of them. So we looked at the different levels of structure. We're focusing in here on A through D, the different types of attractions that can hold our tertiary structure together and also quaternary structure. So we're going to start with the strongest one, with the disulfide bridge. And this is always going to be two sulfurs in a covalent bond. So these are listed from strongest to weakest down here. And if you look, have your amino acid page handy, all filled out. If you look on your page here, the only amino acid that's able to form these disulfide bridges is cysteine. This SH here, it will lose its H and it will form a covalent bond to another sulfur. So here it says describe each attraction. I kind of drew it here, and then give an example of two amino acids that can participate in that attraction. And this would be our tertiary and our quaternary structure. So this would have to be a cysteine that is attracted to a cysteine. And that's it. There's not other examples. Electrostatic attractions are going to be an acid that gets attracted to a base. And if you recall, all of our acidic side chains here have been deprotonated, and all of our basic side chains have been protonated. So that means when I look at charges, that my acids all have negative charges and my bases all have positive charges. If you recall, that increases its solubility, and it's also going to give them the chance to have a really strong intermolecular force between them. So in order to say which amino acids could participate in this, I need to go to my labeled amino acid page and look for an acid and a base. So here, for example, aspartic acid has that polar acidic side chain. Arginine has the polar basic side chain, so that would be a good example. I could say aspartic acid would be able to be attracted to an arginine. All right, now if we take a look back on this slide to see if we can find one of those, notice right here that I have a positive protonated base and a negative deprotonated acid. And so this would be a good example. I could say this is B here, an electrostatic attraction that's holding those two chains together. So this is another good example, and you can see I don't even look at the backbone atoms, I just look at the side chains reaching across and having that temporary attraction. So that's electrostatic. Next down with our polar attractions, we want to look at ion dipole specifically, and so that means I need to have some kind of ion, right, and then something that is polar. The ions are always going to be an acid or a base, and then polar, we had labeled some of those earlier. So let's just be easy here. Pick something that's polar basic because it has an ion on it, and then pick something that's polar. This is going to be an ion and a dipole. And so I could write down that was arginine would be attracted to asparagine. So those two would form that ion dipole attraction where the arginine had the charge on it. These both had charges, right? And you can go through and find your own examples for all of these as well. Next up, polar attractions. So this is going to be hydrogen bonding. Hydrogen bonding, I need to make sure that I have an OH or NH as a donor, and that's going to be attracted to an O or an N. All right. Leave out the ions. There shouldn't be any ions here, so just these OH, NH bonds, and then an O or an N. So if I look up here, again, just kind of start from the top. So the asparagine, I can see has this NH bond, and if I keep going, maybe to the glutamine down here, there's no ions, so that's good, but definitely this NH can donate and hydrogen bond with the CO, the carbonyl here. So asparagine and glutamine. And I think I might have written one of these wrong. No, I think we're good. So asparagine and glutamine, those would be able to hydrogen bond. And remember, when I say that there's attractions here, these would be attractions like this. I can come back here to my page. So I'm looking at some of these polar attractions right now. Notice, for example, here's one of those amide side chains, and this goes to a backbone, so that's a bit strange, but here's a hydrogen bond where I have two atoms hydrogen bonding, so this would be a good example of C that I'm looking at right now. Moving along to polar attractions, dipole-dipole, you're going to see less of these. This is something that's not hydrogen bonding, so maybe something polar like a cysteine and something else polar like a glutamine. I can't hydrogen bond between these because this is not a polarized H, so just something polar with one of those N or O atoms. So I'm going to say as an example, cysteine and glutamine. All right. Finally, nonpolar attractions. These are pretty easy after all of these. Nonpolar is going to be just any two nonpolar side chains. So say something like alanine, where I've got that nonpolar. Glycine has nothing exciting in its side chain, so we classify that as nonpolar also. So maybe an alanine with a glycine would be a nonpolar attraction. And I guess I haven't been writing enough down here, but my polar to polar would be here, and then nonpolar attractions would just be nonpolar to nonpolar. So again, don't forget that there are intermolecular forces between these, and if I can come back to my sheet that had all of the shapes on it, I can find some of those nonpolar attractions like here where it's all carbons, so this would be a good example of D. The disulfide bridge was a good example of A. Here's more of those nonpolar side chains, and so this would also be a good example of D. So those side chains kind of reach out into the space in between the ribbons and the folds and actually hold it all together. So you should now go through all of these and find some other examples, some other possible combinations that you could build these type of attractions out of.